All right, so today's lesson is lesson number 63. We're going to be factoring trinomials. How many terms are in a trinomial? 3, good. So we're going to be factoring these. And today specifically, we're going to deal with when the coefficient, the first coefficient, the a term, is equal to 1. Okay? So this relates to some of the previous things that we've learned about polynomials. Remember when we did multiplying the polynomials, we made the rectangle? So, for example, say I have x plus 4 times x plus 2. I made this box, right? Let's just go here. Okay, I made this box. You don't have to write this. This is just kind of going back to what we did before. So this is what I would get. I would write my answer, I'd write all the terms, and then I'd combine like terms. Okay? So today what we're doing is instead of starting with a product, like x plus 4 times x plus 2, we're going to start with the trinomial and move backwards. So given this, I want to know what were the factors. What were these kind of factors, okay? We've also been talking about the GCF, so the greatest common factor. Okay, that's going to come into play. You'll see the first step is to identify and factor out any greatest common factor if that exists. Okay, but this would be if we have like a binomial times a binomial, we end up with this kind of a trinomial. So now we want to work backwards from the trinomial to a product of two binomials. Okay? Does that make sense? All right. Does everybody have the lesson and objective written down? If you want to make yourself a note, maybe think like backwards of rectangle. Okay, we don't necessarily need to write all of this down, but going backwards from the rectangle method that we talked about. Okay, am I good to move on to the steps? Stop me if not, otherwise I'm moving forward. Okay, a few more seconds. Okay, I'm going to go ahead and move on to the steps now. Okay, so a little wordy today, but these are going to help us for the next 3 lessons, okay? So we'll write them today and then we won't have to write them again, okay? All right, so the first thing we're going to do, like I mentioned earlier, is identify and factor any GCFs from all 3 terms. Okay, so if there's a greatest common factor, we want to get that out. Then we're going to identify the coefficients. So what's A, what's B, what's C? Okay, then we're going to create the factor Xbox. Who likes Xbox? Are we PlayStation people? PlayStation, PC, phone games? No, that's the coordination that I have. That's all I can do. Okay, so different kind of Xbox. Math tool Xbox, which is super fun. This is a really convenient thing for us, though, because it's going to help us. There's kids in Algebra 2 that are like, oh, I have to factor this. Let me do an Xbox. Okay, so this is something that will hopefully stick with you, and you'll be able to keep it as a tool to use in solving future problems. So here's what it looks like. I kind of sketched it on the whiteboard. It's basically, you start with an X with a line through it, and then you will input these values. So A goes on top of the line on either side. Then you multiply A and C together, and that goes up here. Okay, and then B goes down below. Okay. Step 4 says to find the positive and negative factors of AC. So whatever number you put up here, you're going to find the factors of that. Okay, so if I have 4, I could do 1 times 4, or I could do 2 times 2. Okay, you may also need to look at the negative case, so negative 2 times negative 2 also gives me a positive 4, right? We'll see an example, but that's what you're looking for here. And specifically, you want to look which of those factors will add up to B. Okay, so I need numbers that are going to multiply to this and add to this. Okay? Once you find those, you're going to put those factors underneath the A. So they'll go here. Okay, and I know you guys are all waiting, like, what about the box? We see the X. Where's the box, right? Drum roll. It's right here. Ready? So I'm going to look here and here. These are the box portions of the X box. And they're kind of, I'm going to sort of think of them as fractions. Okay, do you see my little air quote fractions here? They're fractions, sort of. So the next step that we're going to do is simplify those. So if I have 2 over 4, I'm going to simplify that to 1 over 2. Okay, does that make sense? So I'm simplifying here. Then I'm going to use these fraction pieces to write a new factored expression. So I'm going to basically tilt this on its side. I'll take the first number and the second number. So whatever I simplified this to, I also have 2 parentheses. Remember, like in the first slide, I said like x plus 4 times x plus 2. Right, so this is the undone version. So I'll have whatever number I get from simplifying goes here. Whatever number I get from simplifying over there goes here. And then I'll have plus some number. And then I changed this to green so you can see this is a different number. So whatever that factor is simplified will go here. And then I'll put an x. Remember, we need the x terms. I can't just have like 3 plus 2 times 2 minus 2 because I'd just get a number. So the x goes in front of the first number for each of our factors. Okay, any questions on that? Okay, so here are our first 2 examples. So I'll make my X box setup. For number 1, I'm going to look at what's A, B, and C. So my A is 1, B is 3, and C is negative 4. I'm going to put A above the line on either side of the X. Then I put A times C in the middle, which is 1 times negative 4, or negative 4. And I'll put the B term down below, which is 3. Okay, now I'm going to look at the factors of AC. So I'm looking at the factors of negative 4. Okay, so I know I have 1 times negative 4, or I could flip that and do negative 1 times 4, and 2 times negative 2. I want to look and see which set of factors here is going to add to my B term. So which one will add to positive 3? If I look at 1 and negative 4 and add those together, I get negative 3. Negative 1 and 4, I'll get positive 3, which is what I want. So those are the correct factors. Moving on to step 5, I'm going to put these factors underneath the A term. So I'll put the negative 1 here and the 4 here. And look at the fractions. I see I can't simplify either of these, so I'll go ahead and write my factored expression. This, from the first fraction, I get 1x minus 1, and from the second fraction, I get 1x plus 4. Okay, the 1 in front of the x I normally don't write, right? That's the kind of invisible coefficient, so I'm going to rewrite this and just do x minus 1 times x plus 4. Okay, and that's my answer for number 1. Moving on to number 2, same thing. I'll look at A, B, and C and place them correctly on my X box. So I put the A term on top of the line on either side of the X. A times C is 1 times 56, which just gives me 56 on top. And B is negative 15. Now I'm looking at the factors of 56. I see these are some possibilities. The most promising one here would be 7 and 8, because 7 times 8 is 56, and 7 plus 8 gives me 15. Except that I get a positive 15. So I want to think, okay, how can I make that a negative 15? And if I think, oh, what if I make both of them negative? Negative 7 times negative 8 is still positive 56, because a negative times a negative is a positive. So I get positive 56, so that's good, and adding them together gives me negative 15, which is what I want for my B. So negative 7 and negative 8 are the correct factors that I'm going to put under A on either side of the X, and I'll look at these fractions now. I can't simplify, so I'm going to write my factored expression. I get 1x minus 7 from the first fraction, and 1x minus 8 from the second. Okay, and again, the ones here are kind of repetitive, so I'll just change this to x minus 7 times x minus 8. That's it for 1 and 2, so pause here and copy this down if you need to add it to your notes. Okay, 3 and 4, very similar, same idea. I'm going to write A is just 1, So that goes on either side. 1 times c is -3, and b is just 2. My factors of -3 would be 1 and -3, or -1 and +3. But in order to get a +2 when adding them together, I want to use -1 and +3. Placing those here, looking at the fractions, I see that I can't simplify. So I'll write the factored expression. The first fraction gives me 1x minus 1. The second fraction gives me 1x plus 3. And again, I'll rewrite these without the leading 1 because it's not really necessary. Okay, moving on to number 4. My a is just 1 again. So 1 times c, which is 36, I get 1 times 36 is 36 on top, and then b goes on bottom. So I'm looking at my factors of 36, and I see that 9 times 4 gives me 36, and 9 plus 4 is 13. So those are the factors that I want here. And I will write my expression. It's important to note that I'm using p here as my variable because that's the variable that's in the trinomial. Okay, so I want to make sure that those go together because, again, remember this is the opposite of our rectangle multiplication, right? And if I were to multiply these two together, I would get that p squared plus 13p plus 36, right? If I had an x, I would get x squared, so I want to be consistent with my variable. Okay, moving on, here's 5 and 6. Okay, in class you guys did these on your own, and you got this as your x box for number 5, so that's k plus 6 times k plus 10. And you would have gotten this as the x box for number 6, so k plus 10 and k minus 2. Okay, the positive 10 and -2 multiply to -20. When I add them together, I get 8, and back to number 5, 6 times 10 is 60, and 6 plus 10 is 16. So those are what I want there. Okay, that's it for today's lesson. Go ahead and work on these, work on the homework, and let us know if you have any questions. Thank you.